Water pollution by Nisha Tailor. The region of Peel takes pride in ensuring that its residents are provided with clean and safe water, free of any pollutants that could jeopardize their health. So the first chemical that I've chosen is nitrate, its formula being NO3 and its state in a gaseous state. So starting off with the acceptable amount to be found in water is 0.00016 moles per liter. The parts per million would be 10 and the parts per billion being 10,000. So the source of the pollutant. Nitrate can be found in groundwater due to plant and animal decay and the continuous nitrogen cycle. The use of fertilizers and sewage treatment can also cause the risk of nitrate in groundwater. Fertilizer residue transfers to soil and groundwater due to the high solubility between nitrate and water. So this is an image showing how easily soil water can seep into larger bodies of water. So next is the environmental hazard. About 7.5% of nitrogen is found in plants, so there's no extreme damage. However, nitrate that leaks into water can possibly result in the contamination of our drinking water, along with the production of algal bloom. An excess of nutrients, which in turn causes deficiency in oxygen, is another environmental hazard. This negatively impacts animals living in water and causes deaths. So the health hazards of nitrate. 2.8% of the human body consists of nitrogen. The body may convert it to nitrate, however. This can lead to the symptom of stomach aches for adults, but something as serious as deadly for children. Methemoglobinemia is the most significant health problem associated with nitrate in drinking water. Nitrite converts hemoglobin to methemoglobin, which lacks the ability to carry oxygen in blood. So this image shows a red blood cell that includes an hemoglobin molecule. However, without it, there is no site of oxygen binding. So preventive measures. Water treatment of municipal plants, constantly monitoring nitrate levels in water, maintaining proper chlorine to ammonia ratio when using a disinfectant. So treatment for already contaminated water would include ion exchange, biological denitrification, reverse osmosis, electrodialysis, and this can reduce levels to 0.022 grams per liter. So the second chemical that I've chosen is benzene. Benzene is a hydrocarbon whose formula is C6H6 and is found in a liquid state. So the acceptable amount of benzene in water is very minimal. It's 0.0000064 moles per liter. The parts per million would be 0.005 and the parts per billion being 5. The source of the pollutant. Benzene is known for its presence in gasoline, insecticides, and detergents. Gasoline spills are the main cause for liquid benzene being present in water. However, some natural sources that produce this chemical include volcanoes, forest fires, which are also fuel combustion, along with crude oil. So this is an image showing a pipeline spill site which releases petroleum into soil. This petroleum contains benzene and this easily seeps into groundwater. Next is the environmental hazard. Benzene can affect the growth and health of plants and even lead to a multitude of plants dying. As a whole, this chemical is low to moderate in terms of toxicity for aquatic organisms. However, water-oriented organisms can be impacted. It is able to exist in groundwater for weeks before being clarified as it breaks down extremely slowly. So the health hazards of benzene. Benzene is categorized as a carcinogen, which is a substance capable of causing cancer in a living organism. It is extremely toxic to human health when ingested and can damage blood-forming organisms. It can also cause neurological damage and harm the immune system, causing more common symptoms known such as dizziness, nausea, headaches, and unconsciousness. So preventive measures would be constantly monitoring to check if levels of benzene exceed the municipal acceptable amount, along with enforcing the use of certified water treatment devices to reduce concentration of organic compounds such as benzene. So treatment for already contaminated water would be coagulation, filtration techniques, incidental volatilization, granular activated carbon absorption, air stripping, oxidization, and reverse osmosis. So the images below show reverse osmosis along with air stripping, which are ways to clarify water that has been contaminated. So that concludes my presentation. Thank you for listening.